Welcome to The Explainer. Today, we're diving into the art of making an argument that's so powerful, people literally can't ignore it. You know that feeling, right? You make this brilliant point, you lay it all out, and crickets. It just vanishes. Well, today, we're going to tear down that problem. We're looking at a framework for building what's called a load-bearing argument, one that can actually stand up to pressure.
And listen, this isn't about just being louder or throwing around big words. It's all about structure, a really disciplined structure. So let's get into it and break down a framework that's built to make arguments that people have to pay attention to.
The guy who wrote our source material, Elias Motzman, he gets right to it. He says the goal here is to stop just giving opinions. The goal is to build a load-bearing claim. Think of it like a pillar in a building. It's so solid that if someone wants to challenge you, they can't just wave it away. They have to attack the specific foundational points.
Okay, so how do you actually build one of these things? Well, the source lays out what it calls a 5-move rhetorical machine. It's this super disciplined structure that basically forces you to be clear and persuasive.
All right, here it is. This 5-step form is the absolute core of the whole thing. The idea is to build your argument piece by piece, locking your audience in at every stage. Let's walk through each one.
First up, the assertion. This is your main claim. You just state it. No hedging, no I think, or it might be, just one single core sentence that your entire argument is built to defend. Boom.
Okay, next is the firstly. This is where you find common ground. You anchor your big assertion to something everyone in the room has to agree on, like a law of physics, a legal text, some kind of structural truth that is not up for debate. This is your bedrock.
Then comes the secondly. I like to think of this as the engine of the whole argument. It's the how. It explains the mechanism that connects that solid ground you just established to your bold assertion. This is where you do the real work, connecting the dots for everyone.
After that, we've got the thirdly. This is the so what of your argument. It's where you show the real-world consequences. This isn't just theory. You point to an engineered result, or a competitor that's failing because of this, or some deadline that forces everyone to act. It makes it real. And finally, the conclusion. And you're not just repeating yourself here. You restate your assertion, but now it's earned. It has weight. And this is where you spell out the stakes and point directly to what has to happen next.
Okay, so that's the theory. But let's see how this thing actually performs in the wild. We're going to use the source's own case study, a really dense one about AI verification, to see how this 5-move thesis handles a complex, real-world problem.
Now, I know this looks like a wall of text. It's intimidating, but believe it or not, this one paragraph contains all 5 moves we just talked about. Let's pull it apart. So, the core assertion is this. The whole AI verification crisis isn't just a simple engineering problem. It's what the author calls a class error. We're fundamentally using the wrong category of tools for the job.
All right, so the firstly grounds the whole thing in basic physics. It sets up a contrast. On one hand, you have physical systems, which are auto-coincident. Think about a rock. Its final position is the log of its journey down a hill. The state and the history are the same thing. But then you have information systems, which are a detached record. The data in a file is totally separate from the log of who changed it and when.
Now for the secondly, the mechanism. Here's the story. Way back in 1945, a huge decision was made in computer design, the von Neumann trade-off. We chose symbolic abstraction, which gave us incredible scalability, but it severed that physical link between a system state and its history. Then, in 1953, Rye's theorem comes along and proves, mathematically, that you can't get that link back just by writing more software. Bottom line, software can't structurally verify other software. It's a proven dead end.
So, what's the consequence? The thirdly, because of that 1945 decision and Rice's theorem, any real solution for verification has to meet 5 brutal structural constraints. These aren't suggestions. They're dictated by physics and logic. It has to be simple. That's sub-Turing. It has to be fast, O of 1. It has to be tied to the physical hardware, that's co-located and substrate bound, and it has to check the system itself, not the data, content independent.
And this is why all the current hot technologies fail. Blockchains, ZK proofs, you name it. It's not that they're bad engineering. They're brilliant, but they are in the wrong class of system. They are structurally guaranteed to violate one or more of these constraints. They just can't work for this problem.
And to make the consequence totally tangible and specific, here it is. This number? It's a U.S. patent application for an engineered system that actually meets all 5 of those constraints. This takes the argument from "here's an idea" to "here's the invention."
So the conclusion lands with a punch. Because this new class of solution now exists, the game has completely changed. The burden of proof has now shifted to all the other vendors. And with a massive EU AI Act enforcement deadline looming, yeah, the stakes are very, very real.
Okay, so we've seen this thing tear through a super complex problem. Let's pull back for a second and ask, why does this form work so well? It's not just a template for an essay. It's really a diagnostic tool for clear thinking.
The reason it's so powerful is because of what it refuses to allow. No hedging, no missing evidence, no disconnected thoughts. You can actually use it to diagnose your own arguments. If what you've written just sounds like your opinion, you probably don't have a firstly. You haven't found common ground. If it feels all philosophical and up in the air, you're missing a thirdly. There's no real-world consequence. The form itself shows you where your thinking is broken.
So, what's the big takeaway from all this? This isn't just some format for a school paper. It's a mental model, a way to build arguments that actually stick and get people to engage.
Assertion. Firstly. Secondly. Thirdly. Conclusion. By forcing you to ground your claim, prove the mechanism, and show the consequences, this whole 5-move structure basically becomes a practical superpower for thinking more clearly and communicating way more effectively.
So there you have it. This structure gives you the tools. It's the blueprint. The only question left is, what powerful, unignorable, load-bearing claim are you going to make?